After taking off and climbing into the clouds and navigating to your destination without ever seeing the ground, you'd sure like to come back down through those clouds and land safely, wouldn't you? Well, that's exactly what instrument approaches allow you to do. With that in mind, we'll look first at the Instrument Landing System, or ILS, which gives you both altitude and course guidance almost right down to the runway numbers. The ILS has basically three parts, and they are guidance information provided by the localizer and glide slope, range information provided by marker beacons and/or DME, and visual information provided by various lighting systems. For now, we'll confine ourselves to the guidance part and explore the others later. There are two separate transmitters with every ILS: a localizer transmitter for left-right guidance to the runway, and a glide slope transmitter that gives you the correct descent angle to the runway. We've touched on the localizer earlier, so let's begin with it and see what else we can discover. Okay, so summarizing what you already know, the localizer gives you left-right course guidance, but unlike a VOR, it only transmits one course. When you're in its single concentrated beam of energy, the CDI needle is alive and off its pegs regardless of this OBS setting. Now, although it doesn't affect the needle indication, experienced pilots set the localizer course on the OBS just as a reminder. Now, you may remember that the localizer antenna transmitting this highly directional beam is down at the far end of the runway. One of the localizer design criteria is that this beam should be about 700 feet wide at the runway threshold. So, now let's flash back in time for some high school geometry, always one of my favorite subjects. Since the localizer beam is 700 feet wide at the runway threshold, the angle that the beam makes is narrower when the runway is longer as opposed to when it's shorter over here. For those 12 and 13,000 foot runways, the beam starts to get pretty darn narrow as you look at it. So to make it practical to fly, the designers have agreed that the beam should never be narrower than 3 degrees or wider than 6 degrees. So for a typical 7,000 foot runway, the beam is 2.5 degrees on either side of the center line, or a total of 5 degrees. And that makes the beam just about 700 feet wide at the runway threshold. You may also remember that a localizer beam extends in both directions from the transmitter. And continuing down memory lane, you know that the beam transmitted in the direction opposite the front course is, amazingly enough, called the back course. The back course signal is not usable for an approach unless a back course procedure has been published. Now, the localizer beam is designed to provide guidance to an airport as far away as 18 miles. Because the localizer is so highly directional, you can expect reliable course signals only when you're fairly close to the published course. Out of the maximum design distance of 18 miles, you can get an accurate signal if you're within 10 degrees or about 3 miles of the course. From 10 miles out, you can receive the localizer signal if you're within 35 degrees or about 5 miles of the course. That same 35-degree width applies all the way down to the runway threshold. Within this reception area, the needle can be trusted to tell you which way to fly to get to the localizer center line, even though it may be pegged on one side or the other. And we need to add a word of caution here. When you are well outside of the localizer reception area, the needle may move around and act like it knows what it is doing. But folks, it lies. It's not giving you a reliable signal, so don't you believe it. Just like tracking a VOR, when you track a localizer, the CDI shows how far you are from the approach course center line. But as you know, with a localizer, the CDI needle is about 4 times as sensitive as with a VOR. So if the localizer you're flying has a typical 5-degree course width, then each dot on the CDI dial face represents only 1/2 of 1 degree. And you can think of that localizer signal as a skinny, pie-shaped wedge in the sky. As you move closer to the antenna site, that wedge of pie gets narrower and narrower. At 5 miles from the runway threshold, a needle deflected 1 dot to the right means that you are about 300 feet left of the localizer center line. But suppose you move to about 1/2 mile from the runway. Well, that same 1 dot deflection will put you only a bit over 90 feet off the center line, which is less than the width of 3 Skyhawks side by side. Hey, we told you this thing is sensitive. It calls for some careful piloting technique, but nothing that you or I can't handle. Well, it's nothing you can't handle. Okay, let's look at the other half of the guidance system, the glide slope. If you have a glide slope receiver in your airplane, whenever you tune in an ILS localizer frequency, you'll receive the accompanying glide slope automatically. And that glide slope gives you the descent guidance to bring you down to the runway threshold. The glide slope antenna, located right here, is normally about 750 to 1,250 feet down the runway from the threshold. And the guidance is usable out to about 10 nautical miles from the runway. The glide path angle is normally set at about a 3-degree angle to the horizontal, but it may vary a fraction either way because of terrain. Now, this 3-degree angle means that at 5 miles from the runway, the glide slope will be about 1,500 feet above the runway elevation. And at 1/2 mile, it will be about 200 feet above the runway elevation. Notice that the glide slope and localizer make a kind of funnel going toward the runway. As you get closer to the runway, the glide slope guidance information gets more and more sensitive, which is why an ILS is so precise, and that's the same way the localizer does it. In fact, it's so precise that when an approach has an electronic glide slope, it's called a precision approach. The electronic glide slope is even more sensitive than the localizer. It's only 1.4 degrees deep, which means it's 0.7 degrees above or below the perfect glide path. At 5 miles from the runway, the glide slope is 475 feet from top to bottom. But when you move into 1/2 mile, it's just 75 feet deep from top to bottom. So at 1/2 mile, if you're just 40 feet high on glide slope, you'll have a full-scale deflection on your needle. Now that's a precision approach, which is why once you get your IFR rating, you'll be a much more proficient pilot than you were before. Now you might think that the glide slope's precise nature makes it hard to fly. Well, have no fear. A well-designed airplane, like your Skyhawk, is quite stable in pitch, so you'll find it pretty easy to fly a glide slope once you get the hang of it. The glide slope transmitter on the ground really sends out 2 different signals. One, a fly up signal, the other, a fly down signal. Now, when the signals overlap, the glide slope needle comes off the peg and begins to give you an indication. Which indication you'll get depends on how much of each signal you're receiving. When the signals are equal, of course, then you get a centered needle. Here it comes down to center now. Occasionally, however, the bottom signal bounces off the ground and creates a false, much steeper glide slope above the real one. You can recognize a false glide slope because it will show either an on-glide path or a fly-up indication when you are at least twice as high as you should be for a normal glide slope at that point. Plus, to keep a centered glide slope needle would require an extremely high rate of descent, at least double the normal rate. A false glide slope may also show as reverse sensing on your indicator along with a lot of needle oscillation. Now, you'll never find a false glide path below the real one, only above it, which is the reason you always want to intercept a glide slope from below. So with the precision course guidance you'll get from an ILS, you'll be able to descend down to a runway in some pretty low ceilings and visibilities. And the best part is that the localizer and glide slope will allow you to do that very safely.